welcome. Before we begin, I just want to thank the Yuan team and Google Cloud for putting together this amazing BigQuery day. So it's great to be part of the event and focused entirely on the real world BigQuery architecture, performance, and the security at the scale. So there is usually a strong lineup here, and the session today covering everything from AI to design to the FinOps and operation. Everything we are covering with amazing folks in the BigQuery sessions. So today we are going to talk about, so in this particular sessions, I'm going to talk about the BigQuery design architectures and how we can manage the data architectures on a BigQuery. So over the years, I have worked on a lot of real world BigQuery systems, and things I have consistently seen is the issues in a BigQuery are not actually the issues because of the query tuning, because of the actual human errors. But what we can see, these are not SQL problems. These are usually a root cause behind the architecture decision. So mainly we are today going to talk about all these architectures problem. Usually the root cause is in the design itself. So in this session, we want to talk about how BigQuery is designed and how BigQuery design works. So this is a different from the traditional databases we talk about like Postgres and Oracle. The BigQuery design itself is different. So we need a different architecture specifically for the BigQuery. Okay. So before jumping into the actual session, so we'll see what things we are going to cover in the session. So just have a quick overview of the agenda, what we are going to cover today. So if you look at my screen, okay, so what we are going to quickly cover today. So why BigQuery is fundamentally different from the other databases. So that is the first thing we are going to see, because that is the core of the BigQuery design architecture. So whatever we are working with a BigQuery, whatever we are designing, it's actually based on the BigQuery underlying infrastructure design that is completely different from the traditional databases. So when we'll move into the schema design, we'll talk about the partitioning, we'll talk about the clustering. These are the performance foundation in terms of BigQuery. Then we'll also talk about, okay, how we can do a query optimization in BigQuery, how the security architectures works in BigQuery, and we'll talk about AI and agentic data cloud. So now everyone is talking about AI, and even the business growth is depend on the agentic AI. So we'll not only talk about the traditional BigQuery AI system, we'll focus on how we can create the agentic data cloud using a BigQuery. So recently, Google has launched the concept of agentic data cloud in Google Cloud. So we are going to discuss about that as well. What are the best practices and how we can utilize this agentic data cloud framework. Okay. So I'm covering few things here. So let me just go to the next slide and we'll talk about, okay, so first thing, this is actually the completely the paradigm shift. When we talk about a BigQuery, so BigQuery is not a traditional database, okay? So if you are thinking BigQuery just like another database, that is the first mistake we are doing in the design and architecture. So that's the first mistake when even the expert persons are doing, because a BigQuery doesn't design, BigQuery haven't designed to work like a traditional databases. If you talk about the traditional databases, these are row-oriented storage. These are having the fixed compute and storage. These are like indexes and primary keys. These are normalized aggressively, and these are having vertical scales. These are having connections and scale. So these are completely different. But if you talk about a BigQuery, so BigQuery is completely a columnar storage. This is separate compute and storage. And if you see the diagram here, so this is about the columnar storage. So BigQuery, it's designed differently. It does not store the rows and the columns together. So it is completely a columnar storage. And it is having the option of completely denormalized aggressively, horizontal and serverless scales, and the option of the jobs and the slots. So this is a different from the traditional databases. So we need to think about the design option also, which are different from the traditional databases. Let's say suppose if you are architecture designing just like a traditional Postgres or the traditional MySQL database way, it's going to hurt the BigQuery, because there are no traditional indexes and execution happens across the distribution workers. The performance tools are mainly partitioning, and these are the not indexes. Okay, so this is also why the heavy normalization patterns are expensive in a BigQuery. So we have to think about that as well. Okay, so now this is the first thing, that a BigQuery is not a database. So we have to stop treating a BigQuery as another database, and we should cover the BigQuery from standard database to the analytical traditional columnar storage database. Okay, now if you talk about another thing here, so the BigQuery execution matters. The model, how BigQuery execution model. So whenever we submit a SQL query, it create a query plan, and that query plan execute on a distributed workload which has backed by the Dremel engine. So you have to pay for per byte scan. It's not like you pay for a query, you pay for a data it is scanning. Okay, these are unused columns. Let's say you are having 10 columns and you are only scanning the data from single column. You are not paying for a remaining column because BigQuery is a columnar storage, and you will pay only for the data you are scanning. And the unused columns are free, so you are not paying. And the shuffle is expensive. Let's say you are doing a lot of data operation before the filtering, then it's going to expensive as it scan a lot of column. So the best practice is always filter first, and then aggregate the data in a pipeline before, and then you can query the data. Okay, so the no indexes exist, so you have to completely rely on partitioning and clustering here in the BigQuery. We can see here in BigQuery, the storage and compute is completely separate. This is how the BigQuery architecture is. So we don't need to worry about the backend architecture for now, because this is like completely managed by Google, and for us it is completely serverless architecture. Okay, but the thing we have to manage how we design our data warehouse, and how we design the data set, how we design the tables, how we design the partitioning, how we design the clustering. So these all things matters while designing the data warehouse or designing the data architecture. Okay, and the schema design, the more important file here is the schema design, how we can do a schema design. So if we are thinking about, okay, just like a traditional databases, that normalization will work perfectly fine for the database, but in BigQuery it's reverse. The more denormalization database you are having, the more performance will be the better in BigQuery. So when joins are unavoidable, put the largest table on the left. So whenever we are putting a lot of joins, then put the largest table on the left. Then you can have the pre-aggregate before joining, so it will have the less data scan, and we are always paying for the number of bytes it is scanning. And as discussed, there are no traditional indexes in BigQuery, and always use int join keys and not a string, because it will slow down the operations. So that a small schema design consideration. Like first thing, we should avoid the normalization. We should keep prefer a flat BigQuery native, the white tables. Okay, and the second thing, when we talk about the schema design, there is a nested and repeated field. Okay, so these usually the traditional database habits. So whenever like the common pattern is migrating the normalized schema into a BigQuery, but that not going to work. So because one scan versus a multiple table join, the single table read replace a triples join. So here the unnest will be parallelized. So workers always expand array in a parallel. So we have to use a nested and repeated feed that will give the better performance. And for the production patterns, you have to use a nested fields, just like a struct or array of struct where we have the nested fields that will help us to improve the performance of the BigQuery. Okay, and whenever we are using this, we have to always use along with the partitioning and clustering. So partition, we have to use a partition column always in the filter, and we have to avoid wrapping it into the functions as well. Whenever we are writing the partition column, we have to avoid, because if we are avoiding, if we are putting that column partition column into the function, it will avoid the partition pruning. Okay, so we have to avoid that. So never put the column into the function. Okay, and the nested structure, so all stored closer to the actual analytical workload. In the BigQuery compress this repetitive field efficiently. Let's say the denormalization is often much cheaper, so the people expect, okay, let's do the normalization just like the other traditional databases. Here in BigQuery, the joins are still valid in many scenarios, and especially when we are using the smaller dimension table, and there are few useful practices as well. So whenever we are using the BigQuery, we'll keep the larger table on the left side, again we discussed, and that will be possible whenever we are pre-aggregating the database schema. Okay, and again let's see about the design practices here. So the partitioning and clustering, this is the core of BigQuery. So whenever we are partitioning, we are kind of the dividing the larger table into the smaller subset. Let's say we are having the data for the 10 years and we are querying the BigQuery. So what happens if even if we are querying the single record, it will go and scan for the whole 10 years of data. But in that case, we don't want to scan the 10 years of data. We just want a particular day of data. In that case, the partition will help. So if we are doing the partition based on the date, it will first check on the partition column as we put the filter. And let's say if data is belong to a particular day, it will scan only that particular day rather than scanning for complete 10 years of data. Okay. And the partition is always has to be date time column. So either you can use the partition date time for the long string or log string data, or you can use a date or the timestamp column. That is the most common. So you can create, let's say, the ingested date or the date, like in your database you are having in a date column, you can use that as for your the partition, or you can have the integer range of like column which can be used for the partitioning. But the most best practice is using the date column which you are having in your database. Now the cluster is again for the precision with the each partition. So when you are having the high cardinality columns which are very commonly used and can be grouped together, so in that case you can use clustering, and definitely it will reduce your cost and improve the BigQuery performance. So whenever you are using the clustering, the order of the clustering also matters. Let's say you are having the country column in your table, and that is the most kind of the cardinal column, where let's say if you are using the country to divide the table, it can be into, let's say, the 4 or 5 groups. That can be the first column to the cluster by, and let's say you are having then the different column, let's say the state or city, then you can use that as well in your clustering. But the orders matters here, so you have to select the most selective column first and your clustering. Okay. And whenever you are doing the auto reclustering, there is no maintenance is required. As data arrive, it will be auto clustered, as your column will remain the same. Okay. So that is the one thing when we talk about partitioning and clustering. So in most production system, what happen, partition by date or timestamp column. So example, there is a event date or there is a transaction date. So when query filter by date, BigQuery only query or the scan the relevant partition instead of the entire table. Okay. And the clustering works with those partitions. So whenever we are using the partitioning and clustering, we have to use a filter on the partition first, and then our second filter will be on the clustering. So that's how it will work. So it will divide your query, it will partition, it will get this subset of the data based on the whole table. It will scan only that subset of data instead of scanning the complete table. Okay. So that is about partitioning and clustering. So if I show you simple example here, so this is from one of my project, and I just created this example. One table, you can see here I created the table and having the Stack Overflow data. So here there is no partitioning and clustering. For a simple query, it is costing me, let's say, for 18 almost a 19 GB. But if I apply the partitioning on the same data, and the data size and columns, everything will be same, but I just added the partitioning here. Here we can see the data size is only around 200 MB. So you can imagine how much it will cost if you are not doing the proper partitioning on your BigQuery table. So it's almost 99% you can say, or the 90% when you are not scanning uh, like the smaller subset and you are scanning a complete table. In that case, you are paying more, you are consuming the more time for your query. So that is the first thing you have to consider when designing the BigQuery tables or the BigQuery schema and the data warehouse design. Okay. And then there is one more concept about the partitioning, clustering, and the partition prunings. So how it works or how it breaks. Okay. So let's talk about the partitioning pruning. So let's look at the partitioning pruning in the practice. So whenever we are directly using the partition column, that works completely fine. When we are using in between clause, it filtering directly on the partition time. In this case, BigQuery can identify the exactly the column needs to be scanned. Okay, and it scanned perfectly fine. So there is no issue. If you can see on the left side, if you are directly using in the timestamp, or you are using the between clause or wrapping partition column with the date. But here in the right side, if you are wrapping your partition column into any of the function, just like a date function, or you are applying the date trunket directly in the filter, the query still return the correct result, but you will not get the benefits of a partitioning, and you are scanning the more data than necessary. And this is one of the easiest way of the cost grow silently over the time. So now the architect will feel, okay, I have applied a partitioning, I have applied the clustering, and I should not get a charge more because my design is correct. But it also matters how you are using your partition column. If you are wrapping your partition column into your uh, what we can say the function, still it is costing you more, because even though only the partition will not help, it will scan the volume increasingly, and it will definitely something worth checking whenever you are reviewing your architecture or how your developers are using the query. So only the partitioning or the designing will not work. You have to set up the correct processes around the BigQuery so it will not break the partition pruning. Okay, so that is the most important thing, because in the production also we observed the issue, the cost hit up very high even though the tables are having partitioning and a clustering. Okay, so we'll discuss a few more common pitfall about a BigQuery design. So there are some issues shown up frequently in environment. Let's say the date shredded table. For example, when we talk about the date sharded tables, instead of the partition, the people also design this way of table, that let's say the sales, the date is, let's say, today's date underscore 2025, then tomorrow's date underscore 2026, and this kind of the date based sharded table. So in that case, it's going to cost you more. It's still going to require a lot of permission and metadata, a lot of the operational overhead. So you have to always do the partitioning and maintain, instead of maintaining the hundreds of table, always use the partition table instead of sharded table. Then the using select star everywhere. So this is the biggest mistake in BigQuery. So it's kind of convenient during the development, like developer go and run select star from development. But in production, a scanning unnecessary column will both cost and execution time, because in production, if you are using BigQuery, then definitely you are dealing with a large amount of data. And if you are doing the select star, then definitely you are going to pay for that large amount of data. So the best practice in BigQuery, always select a required column. So let's say instead of select star, you do a select employee ID, select employee name, and whatever the required column, you can do that. So the very deep chain of views and the top other views, this can make the execution plan harder. So instead of too many small tables or using the overshading, you can have kind of the denormalized table, where you can have the bigger table which the lot of columns, and then you can have the nested schema, the JSON schema, and that will improve the performance. Okay, and the lot of stacked views, that is also the one of the common pitfall in BigQuery. And there is a sixth also, using the cities with the performance. So cities are not materialized, so may execute multiple times. So whenever we are using the common table expression, so sometimes the partitioning prunings will not happen correctly. So always check your query whenever you are using the cities, the common table expression in BigQuery. And the no partition filter is again one of the major design pitfalls. So it's not, we can say, the design pitfall, but let's say we created a partition table. We are scanning 10 TB of data. Our table contains 10 TB of data. We have the partition, but there is no use if we are not using that partition filter. Okay. So these are the things we have to remember. And these are nowadays, even with my experience, I have seen these are the common six design pitfall whenever using the BigQuery. Okay. Now let's check about the security architectures. Now a lot of people feel, okay, important thing, let's say we have set up the correct IAM policy, now our BigQuery is secure. Now BigQuery is not about only the IAM policy, so you have to think about a lot of things: the organization policy or the data residency, where you are storing the data, how you are managing your data, who can access your data, what are allowed region, allowed the policies, allowed the services which can access the BigQuery. So you have to control that using the organization policies. It can be a VPC service control, it can be a region restriction. So all these things will be useful when you are considering about uh, the security architecture of the BigQuery. Then the IAM controls at the project level, dataset level, and the table levels, who can access your BigQuery data. After that, there will be columnar security. Okay, the column level security, that which columns can be accessed by the person. There will be a row level security, and finally there will be a dynamic data masking. So this masking is especially useful when user can access the table, but there are some sensitive value that user is not authorized to see that value. One example I can show you, let's say there is a table and there are some sensitive column. So now developer should access the table, he should query the table for operations, for seeing the data related issues, but he's not supposed to see the actual data. So let's say there is a SSL number, there is a the PAN card number. So the person is not supposed to see that data, but the data is there in the table. So there are two person, one is admin, one is the user. So admin should see the data, but the user should not see the data. But both are having the same level of permission in the IAM, let's say the BigQuery admin role. How you can avoid that? So in BigQuery, so there are the dynamic masking option. So if I show you, that can be done using, let's say, the column level security and using the policy tag. So in column level security, we can use a policy tag. We can create the data catalog taxonomy. We can decide, okay, what is the sensitivity level and the protection level required for our column. So let's say we have a PII data. We can consider, let's say, the email or the SSN number, or the any kind of financial number, the salary payouts, credit card number, and we can categorize also a public data. And we can keep the data masking rule. Let's say a PII data we want only admin can see, but the user data, which is the public data, anyone can see. Okay, so we can do that categorization as well without changing the underlying data. So here we don't need to mask complete data, because we still need that original data in admin operation. Okay, so how we can do that? So I'll show you again a simple example here. So you can see the similar query, similar table. So the left side you can see the admin is querying, the left side you can see the user is querying the data, but he cannot see the salary, and even the SSN number is masked. But the admin is querying the same table and the same data, but he can see the real data. He can see the salary, he can see the SSN. This is because we have created a column level security using the policy tag on two column, the salary and SSN, and we have a two different masking rule. So salary is masked with the null rules. So whatever salary will be there, it can just seen as a null, but actually there is a data. Okay, and SSN number, actual SSN number is there, but we kept the masking rule that, okay, person can only see the last 4 digit. So here you can be control this column level security using two role here. So there are two different role. One is, let's say, mask reader, and another is fine grained reader. So if the person is having the owner access, but he does not have the fine grained reader role, it will not be able to access the sensitive columns. Okay, that is important things, even though the person is the owner. So here we need additional role called a fine grained access reader or fine grained reader. Only then the person will able to see the actual data and not the mask data. So this is how we can manage the column level security and the row level security in BigQuery. So in row level, there are multiple options. Either you can use row level security using the row access policy, or let's say you just want a few columns, you can just create the view with only the certain columns, and then you can give access to the view. So you have multiple options for the row level security as well. Okay, and then designing for AI ML workload. So whenever we are talking about the data, so data is mainly now getting used for the AI, and without data, AI is nothing. So whenever we are designing the BigQuery architecture, we have to also think about the AI, how we can make the easy use of AI, and how we can make our data easily available for the AI. So we can have our data warehouse design where we can pull the data, we can store it in a BigQuery, we can keep in a denormalized formats, partition, cluster, secure, and using Vertex AI, we can export data to the GCS. Either the AI or ML workload needs to work on the raw GCS file, they can use the like well formatted data, well exported data from the GCS, or you can also have the context in the description. So you can write a table description well, you can write a schema for training, you can also partition on the snapshot date. So whenever let's say you are making the data available for AI, you have to think, okay, how your AI will understand the business context. So let's say there is a one table. The table can be, let's say, the orders tables, but how it will order, how it will understand, okay, what this order table contain. So for that, the BigQuery acts like the feature platform for the analytics and the ML workload. So it will contain, if you have the proper description for your column, it will understand the logic behind the table. Okay, what kind of data is available there, and whenever data can be either exported to the Vertex AI, as we discussed here, and can be used for the custom training. So the model also can be trained on the data available on BigQuery, so you can use the BigQML also. And there is also the important architecture decision here. So whenever we are training the data set, it should be point in time correct data. We should avoid the data leakage into the historical training. So always use the latest data for the training. Okay, so that is one important thing to remember here. And partition by snapshot helps to reproduce this data in the model auditing. Then using the materialized feature table, then the separate ML reservation. So we can have, as ML use data heavily, we can separately reserve the ML slot to keep the isolation between the pricing and the slot utilization. And we can have the row security on the training data. So it will prevent analysts from accessing the PII data in the features as well. So again, we just discuss about this PII security. Okay. So we have to think about whenever we are giving access to the data, that one thing also we have to consider, you should not give a complete right access to the data, because there are incident recently that the production database is completely deleted or truncated by the AI. So whenever you are giving the permission to the agent or the AI, make sure you are not giving the full read write permission, and keep the minimum read permission. And even if you need to give any kind of write permission, make you are making completely the audit trail, you are having all the data access logs enabled, you are having proper the data architecture to do the backup and restore of your data. Okay, so that is about the AML. Now the most important thing is agentic data cloud. So this is one of the biggest shift currently happened in the data ecosystem. So in a recent cloud next 2026, Google has launched this new concept of agentic data cloud. So in agentic data cloud, there are few pillars of the agentic data cloud. So this is not a completely new service. So this is first is a universal context engine and the knowledge catalog, where this business meaning of the metadata, business meaning and metadata of your table is stored in the data ecosystem. And it's not only related to the BigQuery and Looker, but also the external system. If you are using like SAP or ServiceNow and other data ecosystem, it will maintain the agent first approach here, and it will work with the all the context. It will maintain the context, and your AI will understand, okay, what is this data about, what this column is all about. And even there is the option for the data agent kit, where you can directly create an agent on your data, and you need to worry about how the agents can be read your data. So in BigQuery itself, you will see the agent now, which can explore your data and will have access to your data. And the cross cloud lake house, so this is again the old concept of a big lake. So now it is kind of rebranded as a cross cloud, where you can connect your other clouds as well. Let's say you can query your data from S3 bucket or Azure blob storage into a BigQuery, and you can have use kind of the completely the big lake architecture in the agentic data cloud. Okay, so you can kind of query and analyze all data in single place using the cross cloud lakehouse. And this is kind of the agentic data cloud architecture, where you can do the agentic development. You can use the Gemini Enterprise. You can connect BigQuery to your Gemini Enterprise. You can build an analytical system. You can have the operational databases, business intelligence, all together using the knowledge catalog, cross cloud, and the AI hypercomputer, which will be used for your ML workload. This is just the architecture overview of the agentic data cloud, and it is not a single product. Is it just the suite of the product in a Google data ecosystem? Okay. So the knowledge catalog, we just like reference it now, how the knowledge catalog works. So let's say without knowledge catalog, agent see the raw data schema, the table, transaction, column is amount, or the column is TS or the promo rate. So it will hallucinate, because it will not understand the concept of this table, concept of this, the business context of this table. But when we have the knowledge catalog, so it will understand, okay, revenue is the sum of the customer transactions, certified gold, and the owner is equal to data science, and it can try to map all the business context to the data column. So it will create the grounded SQL, and it will create a zero hallucination. It's kind of aggregate the native context from BigQuery. It will create the profile data. It will analyze the logs, and it's try to create the enrichment on the missing data. It also do the semantic search. So when we talk about the semantic search, so it's not only the keyword search. It's understand the semantic meaning of the keywords, and then try to create a semantic search on the BigQuery. Okay, and the most important, so like most of you guys heard about this medallion architecture. So this is mostly the concept about uh, related to the data bricks. But whenever nowadays we are using the ELT workload, so where we are doing the transformation within the BigQuery, so we can use this design, the reference design architecture. This is called like medallion architecture, where we can have the raw data in BigQuery landing zone, which can create reference as a data set. So we can have all raw data, immutable data into a landing zone data set. and there we can have the partition data by ingest time. We can append only, will not do any transaction, will not do any kind of truncate. We'll just keep the read only schema. So once data is available in a landing zone, then you can apply your transaction, apply your transformation, apply your business logic, and then you have your denormalized white table data into the silver zone. So it can be your queried zone, and it can be the different data sets. And now here you will have the white tables, you will have properly mapped data types, data is completely validated, null values handled, duplicate handled. You will have proper column and row level security, and it is not the raw data, it will be a catalog enriched data. So this will be your silver zone. But whenever you want to use the data for the business, or you want to use data for reporting, then you will have additional business logic. You want only the specific column, you want aggregated data, you will not need all the data for your business operations, you will not need all the data for your reporting. So there you will create a materialized view. You will have the caching on your BI engine, you will have your domain products, you will have your agent entry point where your agent can access this data in read only mode. Okay, and that will be your gold layer. It will be a serving zone where your actual BI application, your actual users are connected and do the reporting. Okay, and across all these three zones, the few things are matter, that okay, security should be across your all the layer. It does not the way that okay, you are only considering security at the gold layer. No, you have to think about this horizontal line, the knowledge catalog, VPC service control, audit logging, slot reservation, everything should be across the three layer. Okay, so that is about the Medallion architecture, and it is one of the reference architecture used. Sorry. And then we can have some the best practices or the design consideration whenever we are building a data warehouse on a BigQuery. So we always consider about the data volume. Okay, what should be our data? Is it a growing or is it a static one-time load? If it is the volume of data is too huge, let's say the data is the table size is more than 1 GB and it's keep growing, always consider a partitioning. But let's say you are one time load like less than 1 GB, you can keep the partitioning optional. Then the second thing is schema. So you always think about the schema, what type of column you are having, which are the date columns, or let's say you are having the JSON array based column, which are easier for querying, which are having best performance. So you can use that level of schema as well. The usage pattern you have to consider before designing the data warehouse. Okay, how your data will be utilized. It will be utilized by a BI tools, it will be utilized by web application, it will be utilized to the API calls, or it just will be connected to the lookers, because that matters your design, that matters how you will design your architecture, how you will design the columns, how you will design your queries. All this also depend on the usage pattern. And then the loading mode. So how you will be loading your data. Either you are doing the ETL operation, or it will be a ELT, or it will be a CDC, or it will be a daily merge. So based on that also, you have to design and you have to consider, okay, what should be the query pattern, what should be the table design, the schema, partitioning, clustering, because that will be considered whenever you are designing this, and it will impact your cost and performance. Again, the cost and pricing model. So there will be another session where we'll discuss about the FinOps and cost and pricing model, but just in a quick overview. So whenever we are like dealing with the BigQuery, we pay for two things. One, we'll pay for the storage and we'll pay for the compute use. So we have to consider, okay, how much cost will be there for the storage and how much cost will be there for the query. So it is difficult to predict, but at least you can predict the storage, and based on the storage, you can decide, okay, you need a physical billing model or you need a logical billing model. So based on your pricing things, based on your type of data, so sometimes the physical billing model will give you a more benefits. Sometimes it's almost the same, but it depends. Okay, what kind of data you are having, what kind of columns you are having, or if it is just text-based simple column, then you can go with the physical, because in physical billing model there will be a compressed data. Then the backup and retention. So when you are dealing with the production system, you have to prepare for a failure. So even though the BigQuery will provide a very high reliability, you have to always prepare for failure. Let's say there is an outage. Let's say there is an issue with the BigQuery service. Let's say accidental deletion happened, like developer wrongly executed any truncate query, your data is completely truncated. Now in that case, you should have the backup. So BigQuery provide the features like time travel, a snapshot. So you have to think about that, how you can efficiently use the time travel feature. Do you really need a 7 day? If you are having the table snapshot, do you really need a 7 days, or you can keep it, let's say, the 1 or 2 days, just to recover from the accidental deletion. If you are having snapshot, so what is the expiry of the snapshot? You are storing snapshot forever, then you are costing for your snapshot as well. So you have to decide, okay, what should be your DI strategy? What should be your backup and retention? You have to prepare for the failure. You have to do the mock drill about your the failure. You have to do how you can quickly recover your data. You have to think about all these operations, okay? And the agentic readiness now in a modern data architecture, if you are dealing with the data warehouse, you have to think about how you can make your data architecture efficient so even the AI system can use it effectively. If you are making the architecture too rigid, it is difficult to integrate with AI, then you have to think about it once, okay? Because nowadays, if you are dealing with data, then definitely you will have the AI layer on top of it. Even though it's a BigQuery data, it is CSV file, any data you are dealing with will have your AI layer. And as we think about AI, it can be a traditional AI, it can be generative AI, or it can be a agentic AI. So you have to consider that angle also whenever you are designing your BigQuery architecture. And also you have to consider the security. So you should not think, okay, first I will build my architecture, I'll build a data warehouse, and then I will think about security. No, security should be from the day one. You have to design your architecture by security. Okay, so it should be the first step while designing architecture, because in BigQuery, changing schema or changing the feature will be difficult. There is a chance you might lose your data. Okay, so from the day one, we have to think about security. That is the most critical part while designing the production system. So these 8 are the most common design consideration you have to consider whenever designing the high performance and a secure data architecture on a BigQuery. Okay, so I think we covered most of the finds, but from all the session, just want to quickly cover the 5 principle, which can be kind of the goal of the session. Like the storage layout is the performance contract. So whenever we are dealing with the table structure, we have to consider about partitioning, clustering, and also how to query the data. So not only think about partitioning and clustering, so we have to think how we can query them. We have to follow the schema. So we have to not think about just traditional RDBMS. We have to think on the BigQuery, because BigQuery cost on the data you get. You have to think about the denormalized, nested, flattened schema, and you will pay for the data you will read. Security is always a priority. You have to think about security from day one. You have to prepare for failure. You should not think, okay, our system is so perfect that it will never fail. You should always prepare for failure. The day you will get any accidental deletion, you should be prepared to recover the data from the backup and from your DR system. Your agent will inherit your architecture, so you have to prepare that, okay, your architecture can be easily integrated with the AI. Okay, so hope this was helpful, and that's it for this session. And if you have any question, I'm open for the questions. So just let me know if you have any questions. So thanks Yuan again for giving me this opportunity, and we'll see the more interesting stuff in our further sessions.
Yeah, well, thank you so much, Vishal. That was really, really great and really interesting also to take. I know, we started out in the keynote, we talked about a lot of the new features available on BigQuery, and then we went into a kind of practical example of it, and you really helped us come back to also a lot of the important considerations. I think it's always been important, but especially as I think a lot more people are going to start building things on top of BigQuery now, to think about the actual architecture and scaling and observability around those workflows. So thank you for that first off.
Yeah, thanks.
And yeah, absolutely. And then we'll jump into now a couple of questions that came up. I know you were out there answering a lot of the questions that came up during the conversation. And one of the things is I guess let's talk about this. It was a general question asking about observability. Are there any observability features in BQ, or very general, but maybe if you could talk to us a little bit about what should we plan for if we're building on top of BigQuery for observability?
Yeah, so BigQuery observability, like, as it is a serverless, so we may not have the server metrics there, but BigQuery do provide the metrics where we can build, let's say, using the information schema. So the main source of truth is information schema, So using the information schema, we get most of the metric, like who are querying the data, how much data is queried, which table is using more space, which table is highly queried, or any users which are bringing a lot of cost. So that all metrics will get in information schema, and slot related metrics we can get in the BigQuery monitoring metrics. So using that, we can build our custom dashboard. But from based on my experience, I would suggest heavily use the information schema, because there will get a lot of stuff like who is consuming the more data, which query is heavily running, which heavy is costing us, costing lot of storage, costing a lot of the query scan. So all this data will be available in the information schema. So I would recommend highly to use the information schema. That is the first source of truth.
Okay, that's a really great point. And another question that we had come up, which honestly, as a data protection guy, we get this a lot. The question is, how can we go snapshot of a table beyond 7 days? So obviously, if I think we're saying like change history and that type of thing, right? In time travel, we have up to a certain amount of time. But yeah, what are the options if you need to go beyond 7 days of time travel?
Okay, so for BigQuery, in BigQuery, if we talk about the disaster and recovery, we have multiple options as we discussed. So the first is the time travel, where we can have the by default 7 days. If you accidentally deleted something and you want to just go 1 hour back and recover that, where that the time travel will help. That is up to 7 days. But let's say it's beyond the 7 days and still you want to recover using the time travel, you can reach out to Google. There is a fail-safe option, but that is not the self-service. You have to raise a request with the sales team, and then you have to get Google team involved to get the failsafe. That is within the 14 days. But if you talk about the time travel, sorry, the table snapshot, that is the point in time, the snapshot of your table, which contains the whole data, not which is deleted or not which is the time travel. So that have the self expiration. Either you can have the self expiration. Okay, I want to keep snapshot only for 30 days, 60 days, or let's say you want to keep it forever. That's up to us, and it is you can configure it in your BQ console. So for longer retention, we can use the snapshot, but for storage cost, I would recommend keep the expiration for the snapshot as well. Let's say always keep only last 1 month of snapshot or last, let's say, 30 days. And if there is any audit requirement, let's say for the banking data or healthcare data, then you can put it in the archive storage. There is also option for archive storage. Let's say if you don't want to query like frequently in the 90 days, then you can put it in the archive storage. There you will pay less, but you will keep the data for the audit and compliance requirement using the table snapshot.
That's a really great point, and I'd say going beyond that. So we see a lot of use in our customers of the table snapshots, which is a really good way to get that, and like setting a retention policy. And the only thing I'd say is if you're looking for, let's say, for backup or data protection for compliance purposes, where you need a backup in a different project in a different region, we do have a session coming up that's focusing all about data protection options on BigQuery. So that's gonna be coming up.